Hello, I'm Anna Mackay and this video is on rational functions. So thinking about what other types of functions that you know. Linear, quadratic, think about the features of those functions. Visually, what do they look like? So today we're looking at rational functions. Now, algebraically, it's one function divided by another. So there's always a division as a part of it. We will only consider simple rational functions of the form y equals a divided by x subtract b. You may remember from previous videos in this series that we've been looking at direct proportion, and so we've been looking at functions that were of the form y equals a divided by x or k divided by x, where that a is a constant. So these ones, as you can see, are essentially the same, but this time around in the denominator we have a subtract b. So that's going to create some shift in the graph. As I said, so a is a constant, not equal to 0, and having a look at the shape there. Now you'll probably remember from the previous video the shape that you're expecting. So we've got those two curved sort of sections, but they are in an asymptotic nature, so their behavior is asymptotic with a vertical and a horizontal axis. In the previous basic rational function where I guess b is equal to 0, think about where the vertical axis was. That was on the y-axis. This time round our vertical axis, as you can see, is here, and that's been shifted over by how much? By b. So it's moved b units to the right. So for example, if it was subtract 3, so x subtract 3 on the bottom, then our vertical asymptote would be at x equals to 3. And our horizontal asymptote is still the x-axis, so y is equal to 0. Another point of interest here is the y-intercept that can be calculated by a divided by b. Having a think back to, just out of interest, when we had functions of the form, well, in this case, if b equaled 0, y would be equal to a divided by x, take 0. So therefore this y-intercept would be negative a divided by 0 for the y-intercept. Well, anything divided by 0 can't be done, it's undefined. And so therefore the y-intercept, if that doesn't exist, that matches with the idea of the vertical asymptote being at the y-axis. So that fits with what we should expect. So a few notes here. Again, this is called a rectangular hyperbola. The vertical asymptote, just a slight correction here, is that x is equal to b, not 0 in these ones. That the horizontal asymptote is still y equals 0. And that the y-intercept is of the form negative a divided by b, provided b is not 0. So some handy things to write down there. Okay, if you like this video, give it a thumbs up and subscribe to the channel. And the next one, still in the same series but a different chapter, will be 3A, Relations and Functions. Thank you.